Hello viewers, how are you? We were in the process of learning how to write and read and prepare a WPS. So today is the second part. Now we will look into a WPS structure, the basic components of a WPS. What are the basis and guideline for preparing a WPS? How the ranges of a WPS selected? What are the procedure variable, essential and non-essential? What is the basic structure of a WPS? How to compile all the information in a WPS? So let us go one by one. The first query was, what is the basis and guideline for preparing a WPS? How the ranges of the WPS selected? So the basis and guideline of a WPS is, of course, the design code of the project. Design code is deciding which qualification code to follow for preparing a WPS. Three popular design codes for the construction projects are ASME B31.3, which is process piping, ASME B31.4, which is pipeline for liquid transportation, and ASME B31.8, which is pipeline for gas transportation. So B31.3, B31.4 and B31.8, all these three popular international design code are having one thing in common, which is they are referring ASME section 9 to qualify any WPS. So welding procedures for pipeline designed to ASME B31.4 and 31.8 are having another option of qualifying the WPS through API 1104. Being more flexible, most of the contractors like to use ASME section 9 as a qualification code. Latest company standard nowadays openly allow API 1104 or ASME section 9 for qualifying a WPS or the welders. ASME section 9 can qualify all the WPS except there are few specific requirements in pipeline, let's say mechanized welding. So the only option company standard is giving for this is API 1104 section 12. For any hot tap welding, which is also called in-service welding, also we need to follow the API standard 1104 appendix B. Other than that, we can choose ASME section 9 as a WPS qualification code. Welding procedure qualified with groove welds design shall also qualify for the fillet welds within the limitations provided in ASME section 9. Irrespective of the qualification code, API standard 1104 or ASME section 9 used for the qualification. All on-plot piping designed to ASME B31.3 WPS and PQR shall conform to the latest edition of ASME section 9 and the additional requirement of this standard. Also, the specific restriction from the company standard need to be followed. Welding procedure for the structural work designed to AWS D1.1 shall be qualified also in accordance with AWS D1.1. So in this case, for the structure, design code and the qualification code is the same. Whereas B31.3, 4 and 8, they are all referring ASME section 9 or API 1104 for the qualification. AWS D1.1 is a complete code which has its own qualification code also. It has also a lot of pre-qualified WPS which a contractor can directly use for their project after getting the specific project approval from the project inspection. WPS qualification ranges. All the WPS qualification codes like ASME section 9, API 1104 or AWS D1.1 and applicable company standards have specified different welding procedure variables and their ranges. Some of the major considerations should be base metal group and range, wall thickness range, filler metal group or range, welding process and the process combination. Let's say we can have only SMAW or TIG welding, GTAW as a route or filling capping as a manual. So this combination also has a range. Service restrictions or ranges. Let's say if we have a utility line, that WPS will have less restriction in the ranges. But shower gas service is a severe service which will be restricted by many parameters. Electrical parameters ranges based on the well design and configurations. Now we will be discussing the variables which can vary or change are termed as variable, like base metal can change, filler can change, thickness, diameter, electrical parameters all can change. Based on the severity and the impact on the produced weld, the variables basically can be of three types: essential, non-essential and supplementary essential. Changes of the variables which will impact the integrity of the weld, quality of the weld are termed as essential. If you change any essential variable, it needs requalification of the procedure. For example, welding process, base metal, filler, post-welding heat treatment requirement, these are all contributed as an essential variable. Non-essential minor changes like little bit of groove design changes which will not affecting much on the weld metal properties, does not require to or requalify WPS. Diameter changes, method of weld cleaning, let's say we will be cleaning manually, now we will be cleaning with the grinding machine or power brush. So this does not change the weld property that much. So these are non-essential variables. Supplementary essential variable, these variables supplementary or you can say non-essential in some of the service. For example, group number of a base metal is a supplementary or non-essential variable in case of utility service. But in case of shower service, group number will turn to essential variable. Preheating range, base metal thickness range, more restricted in severe service like shower service. So now let us see table number QW253, which describes the welding variables for procedure qualification. The welding process is ASME, shielded metal arc welding. The similar table is available for GTAW, GMAW, SAW and other welding processes also. For better understanding, we have taken ASME as a simple process. In the joints, there are no essential variable. All are non-essential. Let's say group design, backing, root spacing, retainers, everything. Let us understand in the first column, it is written as QW402, then joints. And in the second column, there is 0.1, 0.4, 0.10, 0.11. What are these? That means if you want to get group design, then you need to go QW402.1. QW402.4 is for backing, QW402.10 is for root spacing, and so on. So you know what is the meaning of this. So if you want to know in detail, you have to go to QW402.10 to know the root spacing details. In the second stage, you can see the base metals. Base metals, there are only the thickness qualified 403.8 is an essential variable for ASME. And in the next slide, you can see the continuation, preheat, post-weld heat treatment, electrical characteristics, technique. So from this table, you can easily understand for ASME which are essential, which are non-essential, and which are supplementary essential variables. Now let us see the components or basic structure of a WPS. In this video, we will be discussing in very brief about the basic parts of the WPS. Let's say number one is WPS information, then base metal, filler metal, preheat, post-weld heat treatment, gases, electrical characteristics, weld technique, weld joint design, WPS parameters, position. So these are some of the major portion of the WPS. Let us understand with example. So here you can see quick view of a WPS. It is just for you to understand how a WPS looks. This is half of it because slide space is limited. So I put it in 2 slides. So stay with me. If you like my video, please share to your friends. So now we will be discussing the first module, which is WPS information. You can see at the top, the company name is there. Then we have WPS number, WPS revision, reference procedure qualification record, by virtue of which this WPS is qualified, PQR revision number, then the date when we are preparing or submitting the WPS. Then next line is the application, means where it will be applied. Piping, yes. Pipeline, yes. Pressure vessel, not applicable here. Tank, structural and others, not applicable. Now comes the design code. You see the cross mark means it can be used for any of these design code. ASME B 31.4, 31.8 and 31.3. Why? Because the qualification code is ASME section 9. All these three codes accepts ASME section 9 as a WPS qualification code. So this is the flexibility for the contractor. One WPS they can use for process piping, they can use for liquid transportation pipeline, they can use for gas transportation pipeline also. Then comes the impact toughness, which is ES, which is normally supplementary essential variable. Because of sour service, impact toughness here becomes essential variable. PWST not required. Welding process SMAW means shielded metal arc welding, which is termed also as stick welding, and it is of course manual. Now we will go for the next module. Second module is base metal. There is QW403. So if you go QW403 in ASME section 9, you will find the base metal information over there, their ranges, their restrictions, everything. It will be different if we qualify the procedure through API 1104. Then this QW need to be deleted and we need to put the exact para number for API 1104. Now here you can see P number. P number means parent material. ASME section 9 has a grouping. I will show you in the next slide. The group number also I will show you in the next slide. This WPS is P number 1, group number 2 will be connecting to P number 1 and group number 2. So similar material connecting together. Material specification is API 5L grade X65 and lower to same material API 5L X65 and lower. If we qualify a WPS with a higher grade, automatically downgrades are also qualified. But again, if it is a sour service, a restricted service, in that case group number is an essential variable. Base material thickness range 7.92 to 15.84. So this one we will see later on, means the thickness of the test coupon to 2T, means 2 times the thickness of the test coupon. So our test piece in this WPS was 7.92 mm. So by virtue of which it is qualified 2 times up to 15.84 millimeter. Base material diameter range greater than 73 mm and above. So there is no upper limit. Why it is restricted in 73 mm? Because less than 73 mm in company standard, it is not allowed to weld with SMAW welding. You must weld it through argon route. That's why SMAW groove welds is restricted from 73 mm and above. Any WPS, if the test coupon is butt weld, then fillet will be automatically qualified. We can see the major classifications of base metal in section 9, the right side table. You can see steel and steel alloys are P number 1 through P number 15F for welding, and for brazing 101 to 103. Brazing is not our subject of discussion, so we will be only discussing about welding. Aluminium and aluminium base alloys, you can see P number 21 to P number 26. Copper and copper base alloy P number 31 to 35. Nickel and nickel base alloy P number 41 to 49. Titanium and titanium base alloys are 51 to 53. Zirconium and zirconium base alloys are P number 61 to 62. Now we can see how this P number chart looks. At the right side you can see the grouping of base metal and for qualification. So the WPS we have selected, the material was API 5L grade X65. So you can see the highlighted one, and the tensile strength you can read, you can see the P number, you can see the group number, and you can see the contents, and last column is the SMLS and welded pipe. This is a seamless and welded pipe. So this P number list is a big list where you can see all the materials we discussed as per the grouping: aluminum, copper, nickel, all base alloys. So from the previous table we came to know about the base metal grouping. Now Here you can see the groove weld tension test and traverse brain test details. When the weld test coupon is welded, it has to be accepted through some destructive and non-destructive tests, which we will be discussing later on detail. So here you can see the thickness limit. If the test piece thickness is, let's say, less than 1.5 mm, then the minimum qualification range is T to 2T, and then minimum thickness of the deposited weld metal will be 2T. There are a lot of notes which also we need to read minutely from the standard while preparing a WPS. This one I just put for your example. So there are many variables and many things need to be considered, and your daily practice of preparing a WPS will make you perfect slowly. Diameter not an essential variable for base metal for WPS as per ASME section 9. But for API 1104 there are 3 groups of diameter. Why contractor is accepting this? I told you before, ASME section 9 is much flexible. Diameter is only essential for the welders, not for the WPS qualification. So now third module is filler metal. So you can see the snapshot of filler metal from the WPS. Now let us discuss a little bit. Filler metal F number and A number list from ASME section 9. F number is also the grouping of filler metal. So you can see A7 number 5.1, and you can see 70, 18, 70, 16. A number for the root material is 1. A number for the filling capping material is 10. F number for root and filling capping both are 4. SFA number for root and filling capping is 5.1 and 5.5 respectively. From where we are selecting this? From this table. So filler number you have to select from this table QW432. All filler metals are there. Now the next points are A number. So A number, you can see the table at the right side. These are all A numbers. This is basically grouping of mild steel, carbon molybdenum based on the percentage of alloying component, classification of ferrous metal, analysis number. A number means analysis number for procedure qualification. So you can see the group number 10, 1, which we have used already in our WPS. We have taken for example. Fourth module is preheat and post-weld heat treatment. Preheat and post-weld heat treatment requirement will be as mandated by the design code or company standard. For pipeline project, PWST thickness limitation is very high. That means if any pipe thickness goes beyond 32 mm, post-weld heat treatment is required. That's why post-weld heat treatment is not common and very practical. Post-weld heat treatment, this is a SMAW welding procedure with a lower thickness 7 to 15 mm. So we don't need post-weld heat treatment here. That's why it is not applicable. Now we will see the pre and post-weld heat treatment requirement as per B31.8. Welds in all carbon steel shall be stress relieved when the nominal wall thickness exceeds 32 mm. So you can see here the heating a material to a suitable temperature, holding that temperature long enough to reduce the residual stresses, and cooling slowly enough to minimize the development of new residual stresses. So what is post-weld heat treatment or stress relieving? Which relieves the residual stress developed during the welding. So if the thickness is more, there is a very good chance of residual stresses entrapped in the weld metal, which can develop a crack and failure of the component later on. That's why for the heavier wall thickness, PWST or stress relieving is mandated. Then there is stress relieving temperature also. So here I am not discussing in detail. I have just put for your example. If stress relieving is applicable, then the following steps we need to follow. You can go to this standard and check this para if you are interested. We have discussed for 31.8. Similar requirement we will find also in ASME B31.4. For process piping, as per ASME B31.3, minimum PWST wall thickness for carbon steel is above 20 mm till 2012 edition. There is a major change in ASME B31.3 from 2016 edition and onwards, where PWST for carbon steel are not mandatory anymore, provided a preheat of 95 degrees centigrade is applied for all the welded joint. which is also kind of inconvenient to maintain 95-degree temperature for all the welds. So the company could not accept this drastic change so far. They are still sticking to 2012 standard, where PWST is applicable for wall thicknesses above 20 mm in case of process piping. For pipeline, I told you it is applicable over 32 mm. So you can see the exemptions table on the right side at the bottom, table 331.1.3, where it is exempted starting from ASME B31.3 2016 edition. An alternative post-weld heat treatment requirement for carbon and low alloy steel also in the left table. In case WPS or the designer specifies post-weld heat treatment also for carbon steel, then we need to follow this table. This is also available in ASME B31.3 2016 edition and onwards. Fifth module is gas. SMAW gas is not applicable, but I give you 3 examples here. SMAW, the table will look kind of like this. Shielding gas is not applicable, flow rate, everything not applicable. FCAW is flux core arc welding, which is used in pipeline, automatic welding, or the fabrication also, where a mixture of gases, 80% argon and 20% carbon dioxide is being used. Purity of argon 99.997, carbon dioxide purity is 99.8%, where flow rate has to be mentioned 20 to 40 liter per minute for hot pass, filling and capping. Gas backing flow rate not applicable because no backing is required. And at the bottom, the small table you can see, it is for GTAW, means argon welding. Shielding gas type is argon. The flow rate is 10 to 20 liter per minute. Gas baking flow rate is 15 to 30 liter per minute. Argon purity 99.99%. Gas baking means purging. If in case of stainless steel or alloy steel, the root has to be protected during the root pass from oxidation. Next, very important information in the WPS, which welding inspectors to take care that welder welding within this range or not. This is the electrical characteristics and the weld parameters. These weld parameters during the qualification of the procedure pre-WPS, which I discussed in the previous video, the welding engineer gives a big range of all this data, which has to be proven by procedure qualification record. From the achieved data of PQR, welding engineer again rectifies his WPS with a little bit flexibility provided in the current and voltage range in the company and international standard. Then he has to submit attaching the PQR for approval. If company approves, we can use this data. So let us discuss in short. In the top 2 table you can see GTAW, electrical characteristic. That is a special non-consumable electrode being used during argon welding, which is tungsten electrode. You can see the diameter is 2.4 mm and it is 2% thoriated. Mode of metal transfer, since this is non-consumable, so not applicable. Wire speed range also not applicable. And in the right side table, which is very important, you can see the root, hot, filling, capping, all belongs to GTAW, means argon process. This para is filler metal, which is a alloy electrode, NiCrMO3, nickel, chromium, molybdenum 3. This is a very famous electrode for welding in colloy. Size is 2.4 mm. Polarity is DC electrode negative, DCEN. Current, you can see the range. Then the voltage, you can see the range also, travel speed, millimeter per minute. Then the heat input, minimum, maximum and average. SMAW, you can see electrical characteristic, there is nothing to show, there is no tungsten electrode. The table is also similar. You can see here the root, filling, capping, everything is SMAW. The root filler metal is different, E7016, and the filling capping is 8018C3, which is a low hydrogen electrode. Diameter is not an essential variable, it is written 3.2, but another diameter can also be used. The polarity is DC electrode negative in case of root, and for the filling capping it is DC electrode positive. Current range you can see, voltage, travel speed, heat input minimum and maximum you can see. Now the 7th module is weld technique. Even you can see from the parameter table, travel speed, minimum, maximum is mentioned. Method of back gouging, generally in the single B butt joint we are not doing this. If it is a pipeline, access from inside is not possible, so method of back gouging is not applicable. Backing, this is a GTAW process, the first table. Full argon gas pure purging shall be maintained for at least 3 passes. This is alloy welding, so it is more restricted, so at least 3 passes argon gas purging from inside has to be maintained. Oscillation, no. Stringing bead in the root and waving at the filling capping. Initial and interpass cleaning is brushing and grinding. Orifice cup size for the TIG is 4 to 6 mm. Multiple or single pass, it is single electrode but multiple pass. Contact tube to work distance not required. FCAW, you see the same data is changed. 2 welders operating simultaneously in opposite quadrant in each passes. FCAW is an automatic process, so it is not welders actually, it is welding operator. They are operating from both quadrant, both side of the pipe. Stringing and waving bead are both allowed. Pinning in company it is not allowed. Pinning means hammering on the weld or external force on the weld are not allowed. Passes, it is multiple. Contact tube to work distance, it is important for in the case of automatic welding, is 10 plus minus 5 mm. Back purging not required. Oscillation width of the head during the filling capping, it is 3.8 to 12.3 mm. Dwell time very small, but it is much required to achieve the proper fusion, 100 to 200 millisecond. Electrode is single. Interpass cleaning is through grinding or brushing. Head angle is 90 degree plus minus 3 degree. And torch is single torch. Gas nozzle diameter is 20 to 24 mm. So if you see, SMAW table is very simple. Almost there is no data. But if you compare this GTAW, FCAW and SMAW, FCAW is having a lot of data to incorporate, because this is automatic welding and it is programmed. Okay, now let us go for the 8th module, which is weld joint design. You can see both are almost similar. All are single B butt joint. You can see the detailed figure and the details. The groove angle is 30 degree plus minus 2.5 degree. GTAW SMAW also the same. FCAW also the same. Root face 1.6 plus minus 8 feet is GTAW SMAW. You can see the root face also the same. And root gap 2.5 to 3.5 in case of FCAW, which is root gap is 2.5 to 3.5 for FCAW, and in case of GTAW and SMAW also the same. Bead width is 0.5 to 2.0 ml. This data is not required for GTAW and SMAW. Since this is automatic welding, FCAW, this is an additional data. Misalignment less than 2 mm, less than equal to 2 mm. Thickness of welding layer equivalent to 3 mm. So you can see again here FCAW needs more data to compile. Now we will go to the last module, which is weld position. Weld position, groove all, fillet all, weld progression all. The weld positions I have discussed in detail in my welding basic video. Without knowing the weld nomenclature, it will be difficult to understand the WPS. Limits of the qualified positions for the procedure you can see from QW 301.2, and basic of the positions is explained in the figure 451.1 at the right side. So for understanding, we have discussed the WPS basic structures and have taken ASME section 9 as an example. From the next video, we will take given conditions, what is the final requirement for the welding. Accordingly, we will prepare a WPS step by step. So be with me. If you check all this video in sequence, I hope at the end of the day, you can also start preparing a WPS by yourself. If you like the way of teaching, please subscribe my channel, share it to your friends to inspire me more, and to get my video notification the same time I upload the video. Thank you. Signing off, Showman.